Alright, for today's lesson, we're going to look at the relationship between the angles formed by a transversal crossing two lines. And in particular, we're going to focus on a transversal that's crossing parallel lines. So remember, in order for things to be parallel, they should either have this symbol on the lines telling you they're parallel, or if they name the lines, let's say I named it A, B, and N, you would see the statement A is parallel to B. Remember, that symbol means parallel. So we're going to do investigation with patty paper, and actually we're going to use transparency paper instead. And we're going to see if we can find a relationship between the angles. So the first thing is you're going to take your transparency paper and trace angles 1, 2, 3, and 4 onto the paper. So I'm going to trace line B, and then a little bit of line A. Line N. Okay, make sure you name your angles. This is 1, 2, 3, and 4. So remember, these are not measurements, these are just the names of these angles. So the first part of the investigation has us slide our paper down over angles 5 through 8. So I'm just going to slide it right down on the transversal from where I started. I'm just translating it down to here. Notice what happens. It matches its size and shape with the figures below. So the symbol that we use to represent this happening is congruent. This equal sign with the little tilde or squiggly above it means congruent, which means same size and shape. So if two angles are congruent, they have the same angle measurement. So in this case, we're looking at our relationship. Angle 1 matches up with angle 5 underneath it. Angle 6 is with angle 2. Angle 7 is with angle 3. And angle 4 matches up with angle 8. So if you remember your relationships, these are called our corresponding angles because they're in matching positions. Okay. Next part of the investigation has us spin the diagram 180 degrees clockwise, halfway. So I'm just going to spin this around just like that. So using our example from above, we know that corresponding angles are the same size and same shape. So now looking, after I spun it, which angle does angle 1 correspond with in this case? This time, when I spun it, angle 1 is matching up with angle 8. So angle 1 is congruent to angle 8. Angle 2 is also congruent to angle 7 based on that relationship. And then angle 7 is congruent to angle 2. And angle 8 is congruent to angle 1. If I take off my patty paper, or my transparency, remember these angles are your alternate exterior angles. 1 and 8 are alternate exterior, and 7 and 2 are alternate exterior. So these are your alternate exterior. Using the patty paper in the position that they left us with, it says, slip the patty paper down over angles 5 through 8 and then complete the following. So if I slide my patty paper from the position it was in when we just left it down over 5 and 8, what do I notice happening? It's asking me about angle 5 and angle 6. So angle 5 is matching up with angle 4 and angle 6 is matching up with angle 3. So angle 5 is congruent to angle 4 and angle 6 is congruent to angle 3. And remember, these are alternate interior angles. Because if you look, angle 3 and 6 are alternate interior, and angle 4 and 5 are alternate interior. And they wind up having the same relationship, the same size and same shape. They're congruent. Alright, so based on the information you've gathered, if angle 1 was 123 degrees, fill in the following. So I'm just going to write 123 right here. This is the angle measurement. So now I actually have the angle measurement. So let's use some of the information that we just learned to fill out this diagram. I know that angle 1 is congruent to angle 5. So if this is 123 degrees, that means angle 5 has to be 123 degrees. I also know that angle 6 should be congruent to angle 2. So I'm not sure what this measurement is yet, but we can figure it out. Angle 7 is congruent to angle 3, and angle 8 is congruent to angle 4. Remember, based on the diagram, these angles here, 5 and 8, and 1 and 4, are vertical angles. That means that they're congruent. So I can fill in 123 degrees for angle 8 and angle 4 because of the congruent relationship. So let's put that on the bottom here. Angle 1 is 123 degrees. Angle 4 is 123 degrees. 5 is 123 degrees. And angle 8 is 123 degrees. Remember, when you have two angles on a straight line right next to each other, to find the missing measure, you can just subtract from 180. So if I do 180 minus 123, that'll give me angle 2, because these two angles are a linear pair. So subtracting that, we'll get 57. So angle 2 is 57. And now that I know 57, I know all of the other angle measurements in my diagram. Because these are congruent because they're vertical, and these are congruent because they're corresponding. So all of my missing numbers here are 57 degrees. So the question asks, angle 7 and angle 8 are supplementary, which means the measure of the two angles equals 180 degrees. Angles 7 and 8 also make a linear pair. Why are they considered these type of angles? So 7 and 8 make a linear pair because they are on the same line and they share a ray between them. Same line and share a ray. And vertex, they have the same vertex. Name some other angles that are linear pairs. So looking at our diagram, any of the two that are on the same line and share a ray and vertex are linear pairs. So 1 and 2 are a linear pair, 3 and 4, 5 and 6. Angle 1 and angle 2, angle 3 and angle 4, angle 5 and angle 6. We can also go sideways. If we look at it this way, angle 1 and 3 are a linear pair. Angle 2 and 4 are a linear pair. 5 and 7 and 6 and 8. Let's look at angles 3 and 5. Would angle 3 and 5 be considered a linear pair? Why or why not? Okay, so let's take a look at 3 and 5. So if we look at 3 and 5, 3 and 5 do have two angle measurements that add up to 180, but they do not share a vertex. They share this side here, but they're not right next to each other. They don't share a vertex, and they're not on the same line. So no, they are not a linear pair. 3 and 5 are not a linear pair because they do not share a common ray and vertex. And actually we know what kind of angles these are. These angles are on the same side on the interior. So they're same side interior. And the relationship we can see between same side interior is that they are supplementary. Try the questions on the back and see if you can review some of the relationships that you formed today with this investigation.